blessings of His Holiness, greetings from Dental Education Unit, JSS Dental College Hospital, JSS Academy of Higher Education Research. Dear viewers, good afternoon. Privileged to have with me Dr. Kushalappa sir, Director Academics, JSS Academy of Higher Education sir. Good afternoon to you as well. Team Dental Education Unit extends a warm welcome to you. I'm also joined in by my principal sir, Dr. Ravindra S. Good afternoon and a warm welcome to you too, sir.
Thank you.
Welcome to our esteemed speakers for the sessions, Dr. Praveen and Dr. Krishna. I suppose Dr. Krishna is with us already.
I'm also there. Good morning.
Oh, Dr. Praveen, thank you.
Oh,
thank you. Yes.
Both are looking colorful.
Good afternoon, sir.
Hi.
Hi, sir.
Dental Education Unit, a unit of CCLPE, that is Center for Continuous Learning for Professional Excellence, since its inception has aimed to update faculty and students with current trends in dental education, practice and research through its initiatives. This webinar is yet another step ahead in this effort. In a constantly evolving professional environment, learning agility is the key to unlocking one's own proficiency and meet the challenges. We need to learn, unlearn, and relearn to stay current and also to get ahead. On this note, I request our Honorable Academic Director, sir, who has been our inspiration, support in all our initiatives, to render his opening remarks. Over to you, sir.
Thank you, Sunila. I'm very happy to be part of this webinar and to participate in this interactive session. Also, I hope it will be an interactive session. And I'm so happy that two of the stars in our university, Dr. Praveen and Dr. Krishna, are speakers over here. And the contribution they have done to research and other teaching is immense. What I would like to just add that there's a great trust on research, like Dr. Sunila just said. There's a great trust on research in educational institutions. With abundant amount of research work happening, the publications output is huge. So systematic analysis is very much required to categorically group the publications and results of the previous research done to derive tangible conclusions. And this is what we are going to discuss today, and what the honorable speakers are going to talk to you. And also clinical trials play a huge role in carrying forward the applied aspects of research. We all know the importance of clinical trials, as the whole world is looking forward for a successful clinical trial for the cure of what I'm talking about, COVID-19. So multiple scientific studies from all over the world needs to be studied and individual results collated for the greater beneficial outcome. While meta-analysis and systematic reviews are of great impact and importance. In this scenario, while meta-analysis refers to the statistical tool application for meaningful combination of the data derived from systematic reviews, the entire process is very important with selecting, evaluating, and synthesizing all available evidence. So I know that there are experts who are going to give you more insight into this. This was a little bit from my side, and I'm so happy that this thing is a webinar of this is being organized by the Dental Education Unit. I'm always very proud of Sunila for taking forward the Dental Education Unit, and she plowed a lonely furrow, and she succeeded in that. And now she's got enough help from everybody else. You will do well, Sunila, and take this to greater heights.
Thank you, sir.
And
thank you so much, sir.
The CCLPE also will be very thankful that you all are doing this from the Dental Education Unit. I'm so happy for all this, and I wish your Krishna and Praveen very, very successful lecturing for everyone, and all the participants. I'm sure you'll be benefited from this. Thank you very much Thank you for inviting me. Thank you.
Thank you, sir.
Thank you, sir. Thank you so much.
Thank you, sir. Thank you, sir.
Yes, Praveen. Yeah.
Thank you very much.
Yes, sir. Thanks a lot for your words of wisdom.
Yes.
And this encourages us and strengthens us, sir.
Yes. Yes.
And this webinar definitely now aims to briefly describe these methods in the most easy way to understand by our eminent speakers. Yeah. I just go ahead very briefly introduce the speakers, though they do not need introduction. Dr. Praveen Kulkarni does not need an introduction for those of you who yet to know him. He is a young, dynamic, profound academician, researcher with unmatched fervor to his credit. And Praveen Kulkarni is an associate professor in the Department of Community Medicine and Public Health in JSS Medical College, JSS Academy of Higher Education and Research, Mysuru. He is a FEMA Fellow, a Foundation for Advancements in International Medical Education and Research, and that's FEMA. And is also an alumni of Leadership and Management Program offered by Inclin Trust and IIHMR New Delhi. He has also undergone advanced course in medical education by St. John's Medical College, which is an MCI Nodal Center for Faculty Development, Bangalore. He conducts regular workshops on research methodology, biostatistics, medical humanities, faculty development in education technologies in and outside the institution and across different states. He's also been with the dental education unit across since its inception. He has received research grants for Government of India, Indian Council of Medical Research, Bill and Melinda Gates Foundation. He has been a recipient of Young Scientist Award, Best Reviewer Award, Best Teacher Award, and many more. He is an associate editor of International Journal of Health and Allied Sciences and editorial board member of APIK Journal of Medicine, and also the Rajiv Gandhi University of Health Sciences National Journal of Public Health. He has more than 75 publications in various national and international journals. Thank you, Dr. Praveen. It is a great privilege to have you with us. Thank you for accepting our invitation. And
thank you, Sunila ma'am. Thank you, Kujalappa sir, for the kind words. My pleasure to be a part of this entire.
Thank you too. Thank you too. And the other speaker for today, Dr. Krishna Undela. He is also a young, excellent researcher, academician, and orator. He is a graduate of pharmacy and has completed his MPharm from Naipur, Mohali, and his PhD from JSS Academy of Higher Education Research. He is experienced in conducting pharmacoepidemiological studies and active as an educational session speaker across many countries. Dr. Krishna has expertise in conducting systematic reviews and meta-analysis and has published papers on the same. He has to his credit 50+ publications with a total citation of 700+ and an H-index of 9. An alumni faculty of JSS College of Pharmacy, Mysuru. He is currently serving as an assistant professor in Department of Pharmacy Practice at Naipur since 17th August 2020. Thank you, Dr. Krishna, for accepting our invitation as speaker for this webinar. I wish to forward the session to Dr. Krishna. Over to you, Dr. Krishna.
Thank you so much, ma'am. It's my pleasure. Good afternoon, everyone who are joining here for today's session on systematic review and meta-analysis. And first of all, I'd like to thank Sunila madam, Ravindra sir, Kushalappa sir, and Praveen Kulkarni sir for giving me this opportunity. And I congratulate the dental education unit for taking up this very need of our session, where all of us should learn at least the systematic review and meta-analysis, and especially during this pandemic situation, because we can do all the things in front of our computer. If you know the systematic review and meta-analysis, you can do everything in front of your system, and you can have, at the end of the day, you can have very good publications out of the work what you are going to do by using the systematic review and meta-analysis. So with this, I would like to start my presentation. Today I'm going to just brief, as you have seen in the schedule. So we are going to have two sessions. One is for today and another one is for tomorrow. And for today's session, I'm just going to brief on systematic review and meta-analysis, so that you're going to understand what exactly the meaning of systematic review and meta-analysis, and how we are going to conduct, what all the different steps we are going to follow for conducting the systematic review and meta-analysis. That's what we are going to learn for today's session. And maybe tomorrow, Praveen sir is going to take up the analysis part mainly, like what kind of analysis we are going to do while we are conducting the meta-analysis. So here I'm going to start from the scratch, because I'll keep in mind the people who did not even hear the term of systematic review and meta-analysis. So that's the reason I'm going to start from starting, and I'll take you through the various steps which are involved in the systematic review. And if you see the basic definition of a systematic review, hope you hear the systematic review, but you may not be knowing exact definition for this. And the systematic review attempts to collate all the empirical evidence that fits pre-specified eligibility criteria. And why we are doing this means it is for mainly. So what we are doing here is we are not doing any new research here in the systematic review. We are going to be collate already existing information, which is already available in the literature. And that is mainly the empirical one. It's a real time evidence which are already having. And we are going to be collect all this information based on the eligibility criteria. We are going to have the eligibility criteria before even going to start the systematic review. And why we are doing the systematic review is mainly to answer a specific research question. So even though the name says a review, but sometimes I feel systematic review is more than a research, because we need to spend so much time, money, and energy always. And why we are doing this once again is to find out a research question here. And what are the key characteristics of systematic review? What exactly we are going to be do here? And because I mentioned the systematic review is more than a research, because we are going to be have almost all the components we are going to be have in a research. We are going to be have a clearly stated objectives, and we are going to be have an explicit, that means it's a very clear and reproducible methodology. So we are going to be have a complete methodology for systematic review, and we are going to be perform the systematic search. And that's the main reason why we are calling this one as a systematic review, because we are going to be perform everything starting from literature search. We are going to be perform everything systematically. That's the reason we are going to be call it as a systematic review. And we are going to be assess the validity of the findings. It is not that whatever we are going to be get out of the search, we are going to be included in the systematic review. Certainly we need to assess the validity and the suitability of the articles before we are going to be include them in the review. And we are going to be finally present everything, whatever we are going to be analyzed, we are going to be present everything in a systematic presentation, and we are going to be analyze the results by using some of the various methods. That's what we are going to be call it as a synthesis. So we are going to be have a clear-cut methodology, protocol, and systematic search, everything. And that's the reason always systematic review is going to be considered as a research also. And coming to the another important terminology, that is a meta-analysis. It is going to become always with a systematic review, like a wife and husband. So always we are going to be have a systematic review and meta-analysis. So if you see the definition of meta-analysis here, the meta-analysis is a use of a statistical technique. So we are going to perform some statistics here. We are going to use some statistical techniques to integrate and summarize the results of included studies. So as I mentioned previously, in the systematic review, we are going to be include some of the studies. And what we are doing in the meta-analysis is, whatever studies we are including, we are going to be take the results of each and every study, and we are going to be combine them together. That means we are going to be integrate them, and then we are going to be summarize all the results from all the included studies. That's what we are going to be call it as a meta-analysis. So we are going to be combine all the results from all the studies what we are having, so to come out with one final conclusion. And that's what we are going to be call it as a meta-analysis. I think most of us may have the confusion how to differentiate the systematic review and meta-analysis, because most of the times are going to be come together always. I think this is one maybe best picture where you can understand the clear difference between a systematic review and meta-analysis. Here you can see, so broader way, all of the works we are going to be call them as a systematic reviews only. Okay, so everything is going to be the systematic review, and for some of the systematic review, we can also perform the meta-analysis. So for some systematic review, there may be a possibility of doing the meta-analysis. For some systematic reviews, there may not be a possibility of doing the meta-analysis. Those may come here. I think maybe simple to say, all the systematic reviews are not going to be the meta-analysis, but all the meta-analysis are going to be the systematic reviews. That means if you want to perform the meta-analysis, certainly we need to perform the systematic review. So the first thing what we are going to be do is we are going to be do the systematic review, and if there is a possibility of conducting the meta-analysis, we are going to be conduct. Otherwise we are going to be leave it with a systematic review alone. So the possibility in the sense, for example, if you have the same result from all the 10 studies what we are having, so we can combine them together and then we can pool the results. There is a possibility. But in other aspects, if you take only the the descriptive articles, for example, the case reports and case series, and if you want to perform a systematic review, in that case, from the case reports and case series, we may not get any kind of results. So in that case, we cannot pool the results, and in that case, meta-analysis may not be possible. So the meta-analysis may or may not going to be possible in case of all the systematic reviews. So, and usually we are going to represent, whenever there is a possibility of meta-analysis, we are going to represent them as a systematic reviews and meta-analysis. So what is the importance of doing the systematic review and meta-analysis? I think, hope you heard many times systematic review and meta-analysis. So what is the advantage of doing this? Why we need to perform the systematic review and meta-analysis means, it is mainly depending upon the power of unity. As we know that if you take the strength of every person individually, that may be less. But if you combine the strength of 10 people together, obviously that's going to be much more than an individual strength, right? So similar fashion, in a similar way, we can also take up the systematic review, where by combining the information from all relevant studies, a meta-analysis can provide a more precise estimates of the effect of healthcare than those derived from the individual studies included within a review. So the meaning here it is, if you take up one by one study, maybe if you take one study or if you take another study individually, if you see, the strength may be less. But by using the systematic review and meta-analysis, if you combine 10 different studies of one particular theme, and the result what we are going to get out of these 10 studies is going to be much more better, and they're going to be very much precise than what we are going to get from the individual studies. So that's the reason systematic reviews and meta-analysis are going to be the topmost evidences. Whenever you want to take any healthcare decision, most of the times we are going to be depending upon the information which is coming from systematic review and meta-analysis. Why means, because here we are combining multiple studies together. So when the multiple studies are coming together, the information what we are getting out of it is going to be much more better than any individual article. So in that aspect, we can see the objectives of systematic review and meta-analysis. What are the different objectives of doing the systematic review and meta-analysis? By doing the systematic review and meta-analysis, we can summarize and integrate the results from a number of individual studies. That means we can combine various studies and we can integrate the results into one, and that's going to give more added value. And we can analyze the differences in the results among the studies. So by doing the meta-analysis, we can try to understand, are there any differences between the results of one study to another study, and also we can come out with overcome the small sample sizes. I think that's one more example coming from previous slide. If you take 10 studies which are having 1,000 samples, for example, and if you take the information from 1,001 study which is having 1,000 population, the information may not be much precise. But if you combine all the 10 studies which are having 1,000 people and get the results from all the 10 studies. So now the information is coming from 10,000 people. So the information what we are getting from 10,000 people is going to be much better than what we are getting from 1,000 people. So in that case, if you feel that maybe in any case, the information what we are getting is not accurate, that may be because of less sample size. If you feel that, in that case, if you go and do the meta-analysis or systematic review, you can combine the studies. That means indirectly you are combining the people which are involved in the studies, so that you are going to have more number of people, the more sample size. So when you have the more sample size, obviously what we are getting out of it is going to be much precise in nature. So we can implement directly into our practice. And increase of precision, as I mentioned, when you increase the sample size by combining the different studies, automatically the precision of information, the accuracy of information is going to be much more higher for the systematic reviews. And we can evaluate the effects in subsets of patients. Subsets of patients in the sense, for example, if you combine 10 studies, in the 10 studies, maybe 5 are from India and maybe 3 from USA and 2 from United Kingdom, let us say. And by doing the subgroup analysis, you can try to understand what is happening in India and how it is different from USA and UK. So we can perform some subgroup analysis by doing some subset of, by taking some subset of patients, so that we can understand what is happening in every region or every part of the world. And we can also determine if new studies are needed for further investigation. So after doing the meta-analysis systematic review, still, if you are not able to conclude about the hypothesis, maybe we can say that at present there is not enough information. So still we require some further studies to get the conclusion from those studies. So we can try to say that, and also we can generate the new hypothesis for future studies. So once you find that there are some studies required still, and we can try to find some new hypothesis, and then we can go and conduct the studies. So these are some general objectives of doing the systematic review and meta-analysis. So why we need to perform a systematic review and meta-analysis. And I think one more confusion people will have is how the systematic review is different from a normal review. Hope all of us know what is meant by review article, and how the systematic review is different from a normal review article. So if you see the definition, it's a normal review definition. A normal review means it's a general term for all attempts to synthesize the results and conclusion of 2 or more publications on a given topic. That means maybe if you assign to your student, come out with a review article, what the student can do is he can go and search in the Google or maximum PubMed and get some random articles and read those articles, write something from those articles and come back to you. Okay, that's what is going to be called as a review article. Why I mentioned here the random, what I mentioned is going to be very important. So whatever the publications is going to be take up on that particular issue, he is going to be take up the articles randomly. That means he is not taking all the articles published on that particular issue, right? In a review article. But in the systematic review, what's going to be happen here is the systematic review also review. But what is going to be happen here it is when a review strives to comprehensively identify and track down all the literature on a given topic. So the difference between a normal review and systematic review is here in the review, 2 or more publications may be sufficient for writing a normal review. But in a systematic review, it is not that we are going to be take up only 2 or 5 or 10 articles on that particular aspect. We need to collect all the literature on a given topic. That means whatever the articles published on that particular aspect, we need to collect all those articles to conduct a systematic review. We should not miss a single article on that particular topic which is relevant for the systematic review. So we need to go and search in various databases. We need to search in Google Scholar, and we need to search in PubMed, and whatever the databases are available with you, we need to search all those databases and collect all the articles, and then we can go for the systematic review. So that's going to be the major difference between normal review and the systematic review. And meta-analysis, of course, already you may be knowing this. Here we are going to be perform a specific statistical strategy for assembling the results of several studies into a single estimate. For example, as I mentioned, 10 studies. If you see them differently, you are going to have 10 different results. But if you combine all the 10 different results by using meta-analysis, you're going to have only one result, and that's going to be the final result from all the 10 studies. So we are going to have by conducting the meta-analysis. So this is a major difference between a review, a systematic review, and the meta-analysis. I think this picture is going to be depict much better what I explained in the previous slide. So when you go and search for the literature, majority of the articles are going to be the reviews, normal reviews. In that, some of them may be the systematic reviews. Among all the reviews what we are going to take up, some of them may be the systematic reviews. Among those systematic reviews, some of them may have the meta-analysis as well. So those articles we are going to be called them as a systematic reviews and meta-analysis. So as I mentioned, all the systematic reviews may not have the meta-analysis. Okay, some may have and some may not have. So the systematic reviews which are having the meta-analysis are going to be very minimum compared to all the systematic reviews what we are going to be have it. So that's the difference between a review, a systematic review, and the meta-analysis. I think this slide is going to be very much important, where you can understand some of the major differences between a narrative review and systematic review. The narrative review means it's a normal review. A normal review article, if you see how it is different from a systematic review. So by seeing the article itself, you can come to an understanding either it's a normal review or it's a systematic review. Just by seeing the article, you can get to know that. How means, for example, if you see in the narrative review, usually there won't be any method section. So there won't be any methodology itself in the narrative review. So because there is no methodology, whatever the outcome we are getting out of the review may not be reproducible. We cannot reproduce. So if you give the same topic to 2 or 3 people, 2 or 3 students of you, and if you can ask them to go and come back with a review article, topic is same, but what are the information they are getting may be completely different, because the one person may read the different set of articles, another person may read the different set of articles. So the whatever we are doing here cannot be reproducible once again, right? But in case of systematic review, because we are going to have a clear-cut protocol here, a systematic review also like a research article only. Before even conducting the systematic review, we need to have a complete protocol with us, which is going to have a clear-cut methodology, and that's going to be in detail. We are going to write the methodology. So because we are going to have a clear-cut protocol as well as a detailed methodology, and whatever we are going to get out of the systematic review can be reproducible. That means if I do a systematic review by having set of methodology today, and if any other person uses the same methodology and do the systematic review, it is expected that that person also going to get the same result out of the systematic review. So that's what the advantage of the systematic review compared to the normal narrative review. And some other differences, if you see, there is a limited search. We're going to have some publication bias. We are not going to be. But here in the systematic review, we are going to include all the articles. We are going to do the search comprehensively. We are going to be searching almost all the databases are available with us. We are going to do search in a systematic way and without any language restriction, so that we are going to get very good number of systematic review. We are going to include any article which we come across. But in case of systematic review, mostly we are going to try to restrict with the randomized control trials, the gold standards, because the garbage in, garbage out, right? So you know that. So if you keep the systematic reviews, if you keep the RCTs into a systematic review, obviously the outcome what we are going to get is going to be much more valid than including any other. We may, but mostly it is going to be the RCTs. If you know some basic statistics, p-value and the confidence interval is going to give the, both are going to, confidence interval is going to be much more valid. It is going to give more information than the p-value. And here we are going to use a word counting. That means whatever the article which we come across, we are going to look at them in a similar fashion, right? We don't differentiate an RCT, observation study, a case report in the narrative review. We are going to take the information from all the articles in a similar way. But in a systematic review, it is not like that. We are going to give we are going to give different weightages for different articles. I think the weightages you can understand much better when maybe tomorrow Praveen sir explains about the forest plot. There you can explain about the weightages. Maybe you can try to understand for today's lecture is whatever the articles we are going to be included in the systematic review, we are going to be in similar fashion. One article, the weightage may be more, and another article, the weightage may be less. And mostly the narrative reviews are going to be descriptive in nature, and systematic reviews, because we are conducting the meta-analysis, and they are going to be considered as analytical methods, because we are going to use some analysis here. And that's the reason we are going to have the tower of power. Tower of power means by combining all the studies, you're going to have more number of studies, and that's going to have much power than an individual articles. And it will be subjective biased, subjective in the sense, as I mentioned, the same topic, and they will get the different outcomes, right? But systematic review is going to be objective, and one important point to do the systematic review, at least who are going to be conduct everything detailed. Maybe they're going to be do everything to get not together, to be combined. So because we need to have at least 2 people here, most of the times we can try to avoid the subjective bias. And here a review means any one person can write a normal narrative review. So these are some of the important points we need to understand between the narrative review and the systematic review, so that we can try to see, we can try to appreciate why the systematic reviews are much better than the narrative reviews. And this is a EBM pyramid, that's an evidence-based medicine pyramid. Hope some of you have seen this already, where we are going to be list out various evidences and what comes under the bottom level of evidence and what comes under the top level of evidence, the highest level of evidence. So if we see information from any other studies, usually we'll go on depending upon the background information as well as the expert opinion, if you don't have any other information from any literature. And on top of that, we are going to have the information which is coming out from some of the studies called a case control studies, case series, case reports, cross-sectional studies. So those comes under the the less evidences. That means whatever we are getting from here may not be trustable as accurately. And on top of that, we are going to have the cohort studies. At least a little bit we can trust the results what we are getting from the cohort studies, because we are going to be follow the patients. And as all of you know, whatever the information we are getting from the RCTs are going to be considered as a gold standard, because we are going to be avoid certain biases by doing the randomization, allocation, concealment. So by following all the procedures, we can avoid all those biases. And that's the reason RCTs are going to be considered as a gold standard of evidence. Okay. So we know only the RCTs, but even on top of that, we are having some more evidences. Like whenever you see any critically appraised individual articles, critically appraised means an expert will take the article, he will critically appraise it, and he will give his opinion on that. So that's going to be much more valid than a normal RCT. On top of that, we are going to have the critically appraised topics. In a similar fashion, it is not that one individual article, the group of people who are experts, they're going to be take all the articles on particular topic. They will come out their opinion. For example, guidelines. Guidelines are going to be prepared in such a manner. So guidelines are going to be considered on top of this critically appraised individual articles. On topmost in the evidence-based medicine pyramid, the topmost we are going to be have is a systematic reviews and meta-analysis. So whatever the information we are getting out of the systematic review and meta-analysis, we can consider for applying into our practice, because by doing the systematic review of combining all the RCTs, by critically evaluating all the RCTs, certainly the information what we are getting from systematic reviews is going to be much more valid, and that's the reason they are top in the pyramid. Okay, and especially we can have some normal systematic reviews and meta-analysis, and there is one important organization called Cochrane, COCHRANE, Cochrane organization, which is mainly meant for conducting the systematic reviews and meta-analysis. And whenever you see any information coming out from this Cochrane organization, the Cochrane systematic review, I feel that always that's going to be ultimate. So I think nothing is going to be on top of that. And whatever the information we are getting from Cochrane review is going to be ultimate, and we can certainly use that information for applying into our practice. And coming to the, so that's about the basics about the systematic review and meta-analysis. I think I have given some little bit background, try to understand the systematic review and meta-analysis for the first timers. At least it will be useful for them. What is the difference between a review and systematic review? And coming to how we are going to be conducting the systematic review and meta-analysis, it's very easy in the sense, just by seeing these 4 steps, it is easy, but following the 4 steps is going to be a little bit difficult. So only 4 steps are there. The first step is going to be identify the studies. We need to identify the studies first. Okay, what are the studies we are going to be include into our systematic review? And second one is going to be is once you identify the studies, identify means you're going to be search for the studies. Once you go and search in the PubMed by using any terminology, any keyword, you're going to be get thousands of articles. Obviously, all those articles were not going to be included in the systematic review. In that, some of them may be eligible, some of them may not be eligible for our systematic review. So certainly we need to have an inclusion and exclusion criteria similar to the research work. Here also we are going to have some criteria, inclusion and exclusion criteria. So based on that, we are going to keep some articles and we're going to be discard all other remaining articles. Okay. And the next step is going to be what are the articles we are including here based on this eligibility criteria. Or from, we are going to be read the completely in the sense that's what is going to be take time here. We need to read the articles from top to bottom, from the title till the references. We need to read the article completely, and that's going to be take lots of time. And while reading the article, we can find some important information from every article. It's not that title to references, everything is important. We need to read for understanding purpose. And while reading the article, we can extract the data from each and every article, the information what we required from each and every article. And once we extract the data, and then we are going to be based on the data available from each and every article, we can critically appraise the studies. Critical appraisal is going to be a very, very important step while doing the systematic review. It is not that we are going to be consider all the articles in a similar fashion. We need to critically appraise the studies to understand the quality of the studies. Okay, so if the quality of the studies what you are including in the systematic review is not good, the not useful for the practice. Okay, and final one and very important one is going to be analyzing the data. What are the data we are getting from each and every study? We need to analyze the data. That's what we are going to be call it as a meta-analysis. So for that, we need to try to have some understanding about the analysis part. I'm sure that tomorrow we are going to be get all those analysis part from Dr. Praveen Kulkarni. So I'll go and show you all these 4 steps in detail, what exactly we are going to be do in each and every step. The first one is going to be identify the studies. Okay, it is going to be take a little bit time. 2 authors are going to be do everything independently. If I have myself and another person, I'm going to do the search and other person is going to do the search, and then we can go and combine and then see are there any differences between one person's search to another person's search. So why we are doing this process is try to avoid the subjective bias. Okay, so just for that purpose, every step in a systematic review, it is going to be mainly 2 or 3 people are going to be do individually, and then they are going to be combine it. So for identifying the search, first of all, we need to have a methodology. In the methodology, we need to clearly write what is our search criteria. In the search criteria, we need to have what all the key terms we are going to be used, the keywords we are going to be using each and every database, what we are including. And then we need to mention what all the database we are going to be searched and how we are going to be searching each and every database. For example, most of the times we are going to be considered PubMed or Medline as a gold standard database, right? Where mostly we are going to be go and search for the information, at least PubMed, because PubMed at least is freely available for us to go and search at least. So it is expected that for a systematic review, at least minimum we can go and search in the PubMed. Apart from that, based on the availability, you can go and search in any other database, but PubMed is going to be the minimum criteria to go and search in the database for systematic review. So we can go and search in the PubMed or Medline. PubMed or Medline, it's free to search. You can go and search for the information, but it is up to the article, it is up to the journal if we are going to get the full text article or not. But one important thing I need to mention here, it is, as I mentioned previously, inclusion criteria and exclusion criteria. At any point of time, the exclusion criteria cannot be like, I'm not getting the full text article from PubMed. So you cannot say that you have excluded any article saying that you are not getting the full text article. It is expected that if you want to start a systematic review, certainly you need to have one or other access to get the full text article. Then only you can go and perform the systematic review. So that's a main understanding we need to have. We need to include all the relevant articles, irrespective of if they are having the access or not access, you need to include the studies. And apart from PubMed, maybe you can go and search in any other database, like we have Embase. PubMed is from USA. Embase is a one more important database which is coming from European Union, but it's a paid one. At least to go and search inside the content, we need to pay and we need to subscribe for this. And we have one more important database, is a Cochrane library. In the Cochrane library, especially, you are going to have something called Cochrane Central, CENTRAL, Cochrane Central, and where you are going to get some randomized control trials. And Cochrane is free for us because we are residing in India. So the Indian government is paying for us for the Cochrane library. We can go and search in the Cochrane library freely and get any article. So getting the full text article, once again, depending upon the journal. Okay. So apart from searching in the databases, we need to have some more such strategies. That means we can go and search in the hand search. That means from library. If you feel that there are some good journals in library which are not available in these databases, you can search in the library and get those articles. And one more important step you need to follow in a systematic review is what are the articles you are getting from these databases. you can go and see the references of those articles. You may get some more articles which are not available in these databases. That's a very important step we need to follow. Searching for the references from the retrieved article. Already we have some articles from databases. We need to go and search for the references from those articles, and then you can try to find more number of articles. And we can go and search in the web. In the web, for example, it may not be the Google directly, because if you search in Google, you get many other things. But if you want only the articles, we can go and search in the Google Scholar, all of the published studies. If any study published, we can get from any one of the sources directly, okay? And we are interested to include those results as well. In that case, what we're going to be doing is we can go and search some important websites where we can get some information on ongoing clinical trials, and sometimes we may get the results of interim results also we can get from there, and we can include those results also in the systematic review. For example, you can have various platforms. ICRP, that's an international clinical trial registry platform, which is maintained by WHO, where you can go and see what all the RCTs, randomized controlled trials, which are going on throughout the world. Okay, I think this is a very important one, especially if you want to do any systematic review during the current situation for COVID. If you want to do anything, there are lots of studies are going on currently. So if you want to have some understanding on those studies, we need to go and search for these databases, ICTRP. And similarly, we can have a clinicaltrial.gov that is from USA, where you can try to understand the studies which are going on in USA and other countries. And for that purpose, in India also we have a database that's called CTRI, a Clinical Trial Registry of India. Nowadays, it is mandatory that all the clinical trials which are going on, you need to register first in the CTRI. So you can go and search in CTRI. Just try to see that are there any ongoing studies on a topic what we are currently doing the systematic review. So by following this, by doing this search, this point is going to be very important. If you do the search well, you can do the systematic review very well. Okay, so we need to search in all this data to get the very relevant articles for our systematic review. So how we are going to be search? Search is not very easy, and I'm sure all of you have seen the PubMed, and in PubMed, directly you can see one search box. That's a normal search that everyone knows maybe, but for doing the systematic review and meta-analysis, what we want to know is we need to know the advanced search. If you see the down of the search box, you're going to be see advanced. So if you go and click the advanced, you're going to be get one more platform. So to conduct the systematic review, any one of us should know at least how to search advanced. Then only we can go and conduct the systematic review. That much important it is. So how we are going to be searching the advanced? The search is going to be easy if you know how to take up the keywords from your hypothesis. So for doing the systematic review, obviously we are going to have one hypothesis. And for example, if this is your hypothesis, on this, if you want to do the systematic review, in a 65-year-old male patient with hyperdiabetes mellitus, as well as having the established cardiovascular disease, will empagliflozin compared to placebo prevent the death from cardiovascular causes? That means if you give empagliflozin to a patient who is having the type 2 diabetes mellitus as well as a cardiovascular disease, is it going to be prevent the death from cardiovascular causes compared to placebo? Okay, that's what the hypothesis. If you want to do any systematic review on this particular hypothesis, and it is not at all possible to keep all this 5 lines statement in a search box. If you keep all this 5 lines statement in a search box, I'm sure you are not going to be get any articles. Okay, so it's going to be very bigger. So we don't get any relevant articles if you do a search like that. So in that case, what we need to do is we need to come out with some important keywords from the hypothesis, and identifying the keywords from hypothesis is going to be very important for any search. So what we need to do is, for that reason, we are going to have something called PICO, P-I-C-O. And what are the hypotheses we are going to have? You can try to understand who is a patient, what is the intervention, what's the comparison, and what's the outcome. So what I can do is, now some of the keywords for my search is going to be type 2 diabetes mellitus, the patient who is having the type 2 diabetes mellitus, and another keyword is going to be empagliflozin, and placebo may not be required. Sometimes if it is an active comparator, maybe you can include in the such term. If it's a placebo, I think it is not required to keep in the such words. And then maybe I can keep the cardiovascular death or cardiovascular mortality, the outcome terminology. So frankly speaking, I'm going to have maximum 3 or 4 keywords for any hypothesis. Okay, so I'm going to use those 4 keywords in the search, and in the advanced search, then I'm going to get the relevant articles. And most of the times, what we need to have is, it is not that only those 4 words are important. We need to have the synonyms for that. Why we need to have synonyms means, for example, in all the articles, they may not write exactly type 2 diabetes mellitus. In some of the articles, they may write T2DM. In some of the articles, they mention maybe only diabetes mellitus. Okay, so they may write in a different fashions. So we need to have all the keywords. Along with the keywords, we need to have the synonyms as well to keep in the advanced search, and then only we are going to get the relevant articles. So that's about the keywords we need to have. Once you have the keywords, then we can go and search for the articles in any database. And most of the times we are going to be use some of the popular databases like PubMed, Embase, Cochrane, and we can have Google Scholar. And in our university, we are going to have even Scopus, Web of Science. So we are going to have all these databases access. We can go and search in all these databases, and then we can get good number of articles. And as I mentioned, it is not that once you search, you are going to get thousands of articles. We are going to be include all the thousands. In that, we need to select the articles. So how we are going to be select is once you search, the first thing what we are going to do is we need to read the title. So by reading the title itself, we can understand, is it a relevant article for me or not? Okay, so by reading the title. Once you read the title, if you feel it is relevant, then you can go and read the abstract. And once you read the abstract, if you feel relevant, then you can go and read the full text article. Okay, that's a process we're going to follow. So by reading the title itself, we can understand many articles are not relevant for us. We can exclude them. And by reading the abstract, we feel some more articles are not relevant. Then we can exclude by after reading the abstract. And sometimes even after reading the full text, we can understand it is not relevant. Then also we can exclude some of the articles. So mostly what is going to be happen is during your search, if you get maybe 1,000 articles, by excluding all the irrelevant articles, finally you're going to have maximum of 20 or 30 articles maximum. So remaining all the articles are going to be may not be relevant. And how we are going to be see that relevance is going to be mainly based on the eligibility criteria. So that means inclusion and exclusion criteria. So the eligibility criteria, usually we are going to be keep our eligibility criteria in our methodology. And eligibility criteria we are going to be keep mainly based on our hypothesis. For example, for my study, for my systematic review, I want to include only the randomized control trials. Okay, so remaining all other study designs I'm going to exclude, and I'm going to see only for the empirical flowchart. I don't want the studies on all the SGLT2 inhibitors. I want the studies only on empirical flowchart. So I'm going to exclude all other medications, and I'm going to see the patients who are having only the type 2 diabetes mellitus, and I want only the studies which are conducted on adults, human beings, may not be in children's and may not be on elderly patients. Okay, so like that we are going to have some inclusion and exclusion criteria. Based on that, we can try to see which are included and which are excluded. And most of the systematic reviews, we are going to be usually exclude the articles like case reports, case series, editorials, letters, reviews, and all these articles usually we are going to be exclude from most of the systematic reviews, unless otherwise, if your systematic review is only on these study designs, for example, case reports and case series. And once you've done that, once you've done the procedure, so you have done the search, you have the criteria, inclusion and exclusion criteria, and then finally you have some articles with you which are included in your systematic review. Okay, so once you have that, the first thing we are going to be do is we are going to be have a flow chart like this. We are going to be call this flow chart as a PRISMA. So PRISMA is a very important terminology in systematic reviews. That's a preferred reporting items for systematic review and meta-analysis. Preferred reporting items for systematic review and meta-analysis, PRISMA flowchart. So here it's very simple. We are going to have 4 phases: identification phase, how many studies we have identified by searching in different databases. A screening phase, we have all those, and how many we have excluded based on the abstract, based on the title, how many we have excluded. After excluding all this, how many articles we read full text, and after reading the full text article, how many you have excluded once again. Okay, and finally, how many articles are eligible for systematic review. That's what is going to be the number of studies included in the qualitative synthesis. Qualitative synthesis means all the studies what we're going to be include in the systematic review. And out of all this, for example, 20 we have here. Out of all these 20 studies, all the 20 may not have a quantitative data, so we may not include all the 20 studies for the meta-analysis as well. In that case, what we're going to be doing is, for example, 4 studies are not having the quantitative data, so they're not useful for the meta-analysis. And we can say that we are including 16 studies for the quantitative synthesis, that is meta-analysis. So 20 we are including for the systematic review, and 16 we are including for the meta-analysis. Okay, so this is mainly about, I think, hope you have seen in all the randomized control trial articles, a similar flowchart is going to be there. We can call it as a concert flowchart. There we are going to be explaining about the population, how many we have taken initially, how many we have screened, how many are excluded, how many included, how many randomized, and how many were there till the end of the study. So we are going to have that flowchart in the RCPs. A similar flowchart we are going to have in a systematic review. It is mainly meant for the studies, not for the patients. And once we have the studies, what are the studies you have included? As I mentioned, we need to go and read all the included studies from top to bottom. And while reading the articles, as I mentioned, we need to extract the data from each and every study. So for that purpose, what you can have is you can create one Excel sheet with all the headings, important headings, where the data you required from each and every study. For example, so this is what the data I required from each and every study, so that I can go and create the headings of all this in an Excel sheet. And while reading the article, I'll type it, all the important information in an Excel sheet. So that advantage of this Excel sheet is going to be, you're going to have the important information from all the studies in one Excel. So whatever the information you required for the, you can directly go and refer the Excel. You don't need to go and see the original article again and again. So that's the reason we are going to have the a database for the extraction sheet. So for example, different subheadings, what are the different headings maybe you can have? Name of the study, and name of the author, year when it is published, and the population who are involved in the study. For example, they are from Australia, they are from Asia, so you can get that information. And number of patients who receive the intervention, that is empirical frozen, and number of participants who receive the control, that may be the placebo. And out of the people who receive the intervention, how many got the outcome, the primary outcome, how many got the primary outcome out of the intervention group, and how many got the outcome in the control group. So this is only important information. Like this you can have n number of data from each and every study. You can try to extract the data while reading the articles. So that's what you need to have. That's going to be the complete database we are going to have from all the studies, and that is going to be useful for you for doing any analysis further. Okay, so all the important information from all the studies, we are going to be keep it in one area. That's what is going to be the Excel sheet. And as I mentioned, the next step is going to be, while reading the article, it is not that we are going to be take up all the information from all the articles. We need to assess for the quality. And how we are going to be assessed for the quality is going to be called as a critical appraisal. We need to critically appraise each and every article for the quality. And for that reason, we are going to be have some flowcharts with us. We are going to have some flowcharts with us by assessing the quality. For assessing the quality, concert flowchart is mainly meant for RCTs, randomized control trials. So like that, we are going to have the strobe. It is mainly for the cohort, case control, and process studies. So like this, we are going to have various checklists are available. If you go and see here, the equatornetwork.org, it's a very important website where you can go and get the all this checklist in detail, are all freely available. You can go and get the checklist, and you can follow the checklist while reading the article and try to assess the article critically, so that you can understand how much appropriately they have conducted the study. So we can assess the quality. And the final step is going to be, once you have all the data with you in an Excel sheet, we need to go and analyze the data. Okay, so in the analysis, we are going to have some measures, for example, effect size and confidence interval, heterogeneity, and summary of effects, test for interaction, publication class, and you're going to have two important graphs in systematic review, that is forest plot and funnel plot. Okay, so this is all the analysis we're going to be performed meta-analysis. I'm sure tomorrow's session by Dr. Kulkarni, and you will get to understand what kind of analysis we're going to be performed and how we are going to be come out with a forest plot, funnel plot. And it is not only how we are going to be get all this, how we are going to be interpret all this is going to be very important. I'm sure tomorrow we'll get an understanding of all this. So before going to conclude from my side for today's session, I'll just explain about two important aspects, like that is a relative risk and odds ratio. Because most of the RCTs or maybe most of the observation studies are going to be have the outcome expressed in relative risk or odds ratio. So once you know how to understand this odds ratio, relative risk, then only you can go and use all this in the meta-analysis. So just simple to explain, let us say that your hypothesis is going to be understand is hypertension is a risk factor for causing the cardiovascular disease or not. Okay, and for that hypothesis, when you go and search, you may get some studies which are cohort, some studies which are case control, some may be randomized control trials. You may get various study designs. So from each and every study, you're going to be get some results in the form of relative risk and odds ratio. Okay, so for example, if you see there is one study which is a cohort study conducted to understand the impact of hypertension on cardiovascular disease. And what they have done is they have taken some patients who are having the hypertension 493, who are not having the hypertension, that is 1271. Okay, they have taken the patients who are having the hypertension and no hypertension. And then because it's a cohort study, let us say that they have followed the patients, these two groups, they have followed for 10 years. At the end of 10 years, out of this 493, 90 got the outcome and remaining 403 did not get the outcome, that is a cardiovascular disease. Out of this 1271 who are not having the hypertension, 70 got the cardiovascular disease and remaining 1201 did not get the cardiovascular disease. Okay, and what we're going to be doing is we're going to be give the coding like A, B, C, D coding. Once you give the coding, it's very easy to calculate the relative risk and odds ratio. So this one is A, B, C, D, and this one is going to be A plus B, that is people who are having the hypertension, C plus D, people who are not having the hypertension. Okay, and because it's a cohort study, we are going to be calculating the relative risk. The simple formula for the relative risk is A by A plus B divided by C by C plus D. A divided by A plus B, C divided by C plus D. If you do that, we are going to have 3.3 here. So what we got here is a 3.3 is a relative risk. Let us say that there is one more study where it is a case control study. How they're going to be to the case control study is they're going to be take some cases. The cases means who are having the outcome, that is a cardiovascular disease. Controls, that is people who are not having the cardiovascular disease. So they have taken the cases and controls, and they will go back and see among these cases, among the people who are having the cardiovascular disease, how many are already having the hypertension and how many are not having the hypertension. And among the people who are not having the cardiovascular disease, previously how many had the hypertension and how many are not having the hypertension. Okay, so we are going to be do in a reverse manner, retrospectively, in a case control study. So if you do the case control study, what we are going to be calculating is the odds ratio, and for that, once again, simple formula: AD by BC, A into D divided by B into C. It's a cross multiplication, AD by BC, and if you do that, we are going to be have 3.8 is a odds ratio. So 3.3 is a relative risk from the cohort study. 3.8 is a odds ratio from a case control study. So we are going to have this. And how to interpret this? We have the relative risk, we have the odds ratio. And for the interpretation purpose, that may not be sufficient. We need to have even the confidence interval. This is a very simple form of understanding and interpreting the results of odds ratio, relative risk, as well as a hazard ratio. So what we can understand is, for example, we have the 3.3. So 3.3 is a relative risk that is more than 1. More than 1 means more risk of getting the outcome. And whenever you have this side, the relative risk less than 1, that means it is a less chance of getting the outcome. So here it is 3.3, it is more than 1. So we can say that there is a more chance of getting the outcome, that is a cardiovascular disease, for the patients who are having the hypertension. Okay. And along with that, we need to have the confidence interval. That is 2.4 is a lower limit and 4.4 is a upper limit. And what is the importance of this lower limit and upper limit is to understand the significance. So whatever the 3.3 we got here, is a value significant or not, we can understand. So a very simple way of understanding the significance is whenever the relative risk is more than 1, and also lower limit and upper limit also more than 1, in that case we can say it is a significant. So because 3.3 is more than 1, 2.4 also more than 1, and 4.4 also more than 1, so we can say that this value is statistically significant. And try to understand, here it is 1.4 is a relative risk, 1.4 is more than 1, we can say that there's a more risk just by seeing the relative risk. But if you see the confidence interval, lower limit is less than 1 and upper limit is more than 1. Okay, so in this case we can say it is not significant. Because the value is not significant, I cannot say that there is a more risk. We can simply say that there is no association identified. So whenever you see that there is a no not significant, in that case we can say that there is no association identified. And the last one, you can see here the relative risk is less than 1, and confidence interval, both the values, lower limit and upper limit, also less than 1. In this case we can say that because the value is less than 1, we can say there's a less risk of getting the outcome. When the people are having the hypertension, they're having less chance of getting the cardiovascular diseases. So that's what they're going to be understand. And the value is found to be significant as well, because both the lower limit and upper limit are less than 1. So with this, I'm going to conclude. From here onwards, maybe tomorrow's session, you're going to be listen Dr. Praveen Kulkarni about the forest plot and try to understand the forest plot, and all other analysis we are going to be have in meta-analysis and how to interpret all those. I'm sure you're going to be learn all those things tomorrow from Dr. Praveen Kulkarni. So thank you so much, ma'am. So that's from my side. If participants are having any questions, maybe we can take it up.
Thank you for the presentation, Dr. Krishna. There are a few questions in the chat box, but we shall try to take it tomorrow because we are running off time. And tomorrow, all the participants kindly note that tomorrow's session will start at 9, not at 12 o'clock in the afternoon. And Dr. Krishna will also be there along with us. So at the end of Dr. Praveen's sessions, we shall try to go ahead answering the questions. Good morning to all the viewers who has joined in today for the session. Our speaker, Dr. Praveen, is already introduced, and as said yesterday, he needs no more introduction. So I think, Dr. Praveen, you can start. We have a time constraint of being closing at 10:30 today. So let's get in. And as you finish the session, we shall proceed into the question and answers of yesterday's and for today.
Hey, good morning, everyone. So thank you very much, Sunila ma'am, for giving me an opportunity to speak on this very important issue. And I'm just taking the things forward as Dr. Krishna was talking yesterday. So systematic review and meta-analysis is one of the very important core area of competency which most of us as healthcare professionals are not very competent with. So that is the reason we need to learn about it, we need to practice it, and we need to disseminate information related to it to the higher level of large number of people, so that this method becomes a more useful method. Because this is an era of evidence-based medicine. So for example, you might have seen a lot of news coming nowadays on one of the health specialty. They discovered something called as a COVID vaccine, and they wanted to, make it marketable, use it, and when it was submitted to the agencies, the Drug Control General of India, they said this is not done according to the requirement. Okay, and some of the medicines, some of the drugs which come into market, they will be having questionable level of efficacy, questionable level of effectiveness. And so all these things are very important, because when we synthesize results from various studies, we try to get a better kind of a picture at the end of the day. Okay, so as this is an evidence-based medicine era, for everything we want to advocate, we need to have some sort of an evidence associated with it. And that evidence should be more synthesized evidence, and that evidence should be more visible to everyone, and that evidence should be statistically proven. Okay, only such evidences are going to be taken into account. So that is the reason from where the collective evidence arises. The collective evidence arises when you analyze the data of very systematically conducted research. Okay, so a very simple thing is, I may conduct an RCT. I may conduct an RCT with 1,200 individuals. Another person may conduct an RCT with 200 individuals. One more person may conduct RCT with say 300 individuals. But conducting RCT is not a very simple phenomenon. It is a very complicated business. And having large-scale RCTs with the drug interventions we have is a very challenging task. That is the reason if you take 10 different RCTs with 1,000 to 1,200 sample size, so your overall sample size is going to be very large, and the evidence that comes out of it is going to also be very large. That is the reason meta-analysis is, as we proceed further, as we have large number of studies available, the evidence we generate are going to be of good quality. That is the reason we do a lot of meta-analysis and systematic reviews, which are the analysis of already done analysis, meta-analysis, analysis of already done analysis. That is the reason the strength that comes out of the meta-analysis or the systematic reviews are going to be very strong. Yesterday, Dr. Krishna was talking about the evidence pyramid. We have lot of different type of studies. There are now, we have something called as hybrid study designs which are coming out. But with all these things, which is the best possible way of getting a very good evidence, a gold standard quality of evidence? The gold standard kind of study designs as we advocate as of today are the randomized control trials. What a well-conducted meta-analysis, which includes multiple randomized control studies, is going to give more, authentic information compared to a single RCT. That is the reason the scientists now keep this systematic reviews, not all systematic reviews, but the meta-analysis at the top of evidence pyramid. The evidence pyramid, the top of evidence pyramid, the peak of evidence pyramid is denoted by the meta-analysis. The whole reason for this is there is going to be a major synthesis of different RCTs, and the evidence that generates out is going to be of great value. Okay, so this is what we call as great chain of evidence. Let me ask you one simple question. We publish multiple papers every year. So we publish 2, 3. Our university also gives a kind of requirement. Every faculty has to publish 2 papers every year. My simple question is, how many of you read the papers published by your colleagues from your same institution? How many of you read the papers published by yourselves for the second time? If we ourselves are not reading the papers which are published by ourselves, who else is going to read it? That is a major problem that most of us are facing. Now the COVID, after COVID has come out, people say there are multiple pandemics associated with COVID. One is a COVID pandemic, other is something called infodemic, where there is a lot of false information spreading, and third one is more important, it is called as paperdemic. Lot of papers on COVID-19 are getting published. One of the bibliometric data analysis that was done by one of the team with which I am associated in New Delhi, they said according to their evidence, there are around 1,200 papers on COVID-19 published in 1 month across India, only India. So who reads those 1,200 papers? So there should be some mechanism that we need to extract the most important components of those papers and publish it as, you know, something which is a collective wisdom from all these papers, so that it becomes more visible. So that is the reason evidence-based medicine, which takes evidence from multiple sources and brings it at one area, which is a major area, which is a major component that we all need to look at. Okay, so often we have limited time to use the literature published by ourselves. One, we may not find the time to do the proper review of literature. We won't be having adequate competency to evaluate the papers, what is right, what is wrong, and we have very limited information about application of the information that we have identified over a period of time through all these literatures. That is all the reason we have to do a collective, we have to learn about meta-analysis, we have to learn about systematic reviews, and we need to proceed further. Dr. Krishna was talking about, Krishna talked a lot about the most important areas of meta-analysis. He very explicitly mentioned what is the difference between meta-analysis, narrative reviews, systematic reviews, and just a review article. I'll just give you one example. As a reviewer for few journals, people say, I have written a review article. And when you look into that review article, it will be exactly same as you give your son or a daughter to write an essay about environmental pollution in India. The way he writes or she writes and the way paper comes to the journal are absolutely same. And how do I consider it as a systematic review or meta-analysis? Mention it is a systematic review on environmental pollution. I'm just giving you a very general example. Another common source of people say a review is a PG presentation, seminar presentations. As postgraduates, we do the seminars and we make 20-30 pages, a document, and that itself is published as sent as a review article. And for any review article, there should be some amount of literature support and some kind of a debate that should take place. Unless you make a debate about the findings of different studies, it cannot be called as a review article. You will be just saying, this is a pathogenesis, this is pathophysiology, this is the diagnostic procedure, these are the treatment options, these are the outcomes. If this is mentioned, like you write a typical chapter in a textbook or an essay, then that cannot be called as a review article. I want to give you one hint. There is something called Glassix 6 standards. Glassix 6 standards, that is, I think Dr. Sunila and other famous fellows who are there here, they can connect it with very easily. This Glassix 6 standards is one kind of a standard checklist that is available if you are really interested in writing a scientific narrative review article. Please try to follow it. I'm just taking the things as Dr. Krishna was talking yesterday. I'm just taking it further. This component I just want to add, and then I'll go to the other steps. In any systematic review, it is not one person's business, it is a teamwork. Do not do the systematic review sitting in one corner of your room and closing the laptop when someone enters into your room. Make it very clear that it is going to be a teamwork. And who should all be there in the team? At least 2 people. One to at least critically analyze what you have written. But we suggest around 4 to 6 individuals in a group of meta-analysis or systematic reviews with very clear-cut divisions. And when we say this, people say we have a team of people who are doing systematic review or the meta-analysis. And when we really go and inquire, there will be one person who will be doing everything and others will be just giving him moral or physical support. That is not correct. Systematic review is a collective wisdom, please remember. Or the meta-analysis is a collective wisdom. What? The whole reason is the same. You cannot rely on one person's information, one study's information, and you collect several studies and you come out with some wisdom. For that, you need to have a proper team. And in that team, there should be one methodologist who should be a devil's advocate, who knows everything about how to review, search the literature, how to write a literature matrix, and how to extract the data and how to collate it, compile it. All that information should be available with a methodologist who is having specific training in meta-analysis or in the systematic review. And there should be one with clinical expertise. If you are doing study on it could be a dental or medical or something related to pharmaceuticals, there should be one clinician who is a person who applies the knowledge, and there should be one statistician who is very much essential. As I talk much about statistics today, I think you will be able to connect yourself why statistician is very much essential to be a part of this entire team. And still discusses the interests. They say this is my mutual area of interest, and they decide on the roles and responsibilities of each one of them. And if there is any need for funding, the reason why I'm putting this slide is there are some agencies which can give funding to the meta-analysis also. You may consider, you may surprise, why do we need funding for meta-analysis? Dr. Krishna was telling yesterday, if there is any article which is, if you mention that I was not able to download the full text of this article, this study cannot be a meta-analysis. At least for subscribing to the literature, at least for downloading the papers, and to apply to the funding agency and to apply to the Cochrane, you need to have some amount of funding. And that funding can be provided either the academic institutions, or it can be National Institute of Health, NIH, can give some kind of grants for systematic reviews and meta-analysis. I have not seen ICMR, DBT, DST, on which we heavily rely on the research in India. So they have got any component of funding for systematic reviews or meta-analysis. The matter scope can go to such an extent that when I was in one of the expert committees in ICMR, they were saying, why should we really fund for the epidemiological studies, the cross-sectional studies? We are not going to fund. We are going to fund only the diagnostic studies. If the conditions are of that kind there, for the cross-sectional or epidemiological survey-based studies, I really doubt what kind of funding they are going to provide to the systematic reviews or meta-analysis. They want one, primary data is the one that is a major area on which they are working about. But this is, institutions can give the funding for systematic reviews and meta-analysis. At least they can subscribe to the journals. They can have journal subscriptions. For example, how we have for the Scopus, we have for the Web of Science. At least those subscription components, if the institutions can take care of, researchers can download the articles and they can publish as a systematic review and meta-analysis. There will be usually request for proposals from the NIH on comparative effectiveness. We just keep seeing these components, but it's a very exhaustive process. You need to update a lot of a very stringent application process, and it has to undergo several registrations, and then you will be eligible for funding from NIH. But there is an option, just to keep it in your mind. Okay, so the protocol, whatever we write out of this entire, systematic review, most of the time we say I'm doing systematic review or meta-analysis, and we do not have any protocol in and what I want to do at the end of the day. There is no protocol at all. And I start, most of the things in India for the researchers like us, it all comes with the intuition. Today I saw 10 patients, I want to do systematic review about this particular condition today. Someone discussed something, I want to do systematic review. And what I do immediately after I conceive that idea, I start downloading the papers. I download 200, 300 papers and I keep in a D drive. And I won't have time to look at all those things. But if you are having that intuition, please go with a protocol. Write a protocol, what I exactly want to do in it. Doing initial 10 to 12 papers, that is going to give you an idea what exactly is to be done. And then synthesize your idea as a protocol. You can submit your relative review, protocol to the Cochrane. If you register your systematic review or meta-analysis with Cochrane, it will undergo a very thorough revision with a think tank that is situated there, and they are going to give you very good inputs. Based on that, your whole systematic review or meta-analysis is going to improve. registering to Cochrane, let it get rejected. There is no problem, but they are going to give you real-time, more practical, very important information. Okay, so that can be utilized for further building up on your systematic reviews or meta-analysis. Okay. These are the steps of conducting any systematic review or meta-analysis. Dr. Krishna has already told most of them. He started with formulating a question. He told you something called as PICOT statement, PICOT checklist. He told you about what are the inclusion and exclusion criteria, which studies are to be included, which studies are to be excluded, locating the studies, selecting the studies, and he also told you about how to assess study quality using the PRISMA guidelines, the checklist that he was talking with a lot of practical importance yesterday, and extraction of data. So Dr. Krishna has covered all these steps and made my life very easy to concentrate majorly on two important components. One is analyzing and presenting the results and interpreting the results. So for next 30 to 35 minutes, I'll be talking only about how to analyze and interpret the results of systematic review and meta-analysis, and how to proceed further. I took this much of time of you for the reason that I wanted to see some number of participants in the participant gallery. It has increased from say 49 to 97. Now I can confidently talk about statistics, because when any time when you want to do systematic review, or when you are reviewing the paper, when you are doing the journal club, these are the common questions that arise from any corner of the campus, and they are directed to us. Sir, how exactly this has to be interpreted? Because if there are many number of participants, we can confidently go ahead with the component of analysis. When we want to analyze the data, I took few of the slides from Krishna so that there will be some amount of continuity. And when you want to analyze the data statistically about the meta-analysis, there are few components that you need to remember. One is something called as effect size, about which relative risk, odds ratio, and hazard ratio, risk ratio, and standard error of mean, the difference that Dr. Krishna has already told yesterday. I am again not going to touch on it. Krishna also taught you beautifully about 95% confidence interval. Please remember, a graph is put with one central line, that is the line of null value, null hypothesis. On either side there will be distribution of studies, studies 95% confidence intervals. And when do you say the 95% confidence interval is statistically, the effect size is statistically significant or not, using the 95% confidence interval is explained it in a most clear manner. Today I am going to talk about testing of heterogeneity, which is a very important component of statistical analysis, and estimating the summary effect, and test for interaction, and finally the publication bias. These are the four areas on which I'll be talking about today. In any kind of systematic review and meta-analysis, these are all the measures. You need to be very clear what are going to be my measures and how I am going to interpret or depict my measures. Those depictions are through the forest plot or the funnel plot. These are the two very commonly used type of statistical analysis tools in analysis ways in the systematic review and meta-analysis. Any meta-analysis statistical analysis of any systematic review. Systematic review I will not be talking much, because it is more of a narrative business, it is more of comparing business. It is, I am just going to put it aside, but I will be talking more about meta-analysis, which requires statistical analysis. So in any meta-analysis, there are three important components which are required. Number one, pooled estimate. I have done a study and I have got this standard error of mean, or this odds ratio. Dr. Brinda has done one study and this is her odds ratio. Dr. Sunila has done one study. This is her odds ratio. Sumukh has done one study. It is his odds ratio. Krishna has done one study. It is his odds ratio. There are 10 different odds ratios. And all these odds ratios are not absolutely going to be same, because all of us are having different set of populations. But all these are different odds ratios, but if you club all of them and calculate one odds ratio for all these studies, that is called as a pooled estimate. Please remember it, pooled estimate is nothing but if you take all different effect size or outcomes and if you pool them all together, and whatever final effect you are going to get is called as a pooled estimate. And this pooled estimate could be just because of chance, or it could be a statistically significant variant, or statistically significant estimate. And the pooled estimate says that we 6 did different studies on the relationship between lung cancer and smoking. I got odds ratio of 12, Krishna got odds ratio of 8, Sunila madam got odds ratio of 10, Ravindra sir got odds ratio of 16. And when I calculate the pooled odds ratio, that may come as 12. And the pooled odds ratio can be, what does this suggest? A person who is a smoker is 12 times at risk of developing lung cancer compared to a person who is a non-smoker. And whether this strength of association odds ratio is a true estimate or it is just because of chance, we need to test it statistically. And then we need to check for heterogeneity of the data. Heterogeneity is a rule rather than an exception. There will be heterogeneity. The heterogeneity between the studies, heterogeneity in outcome between the studies. And there may be one person who may emerge at the end of the day and he says, heterogeneity odds ratio between smoking and lung cancer was just 1.2, but all of our estimates are more than 5. There can be heterogeneity, and we need to check whether the heterogeneity occurs across the studies. If the heterogeneity occurs across the studies, it means that the studies are not comparable. Okay, so we need to think about these 3 components when you are doing the statistical analysis of any type of systematic review. I want your 100% attention on this particular graph. This is a most primitive type of the forest plot that we come across. A very primitive type of a forest plot. And I'm going to take you further with a commonly used forest plot now, but try to understand what is the concept of forest plot or the pooled estimate. In any type of a forest plot, we put our outcome in this type of forest plot. We put our outcome, that is relative risk here, which is in the logarithmic scale. Logarithms are all done to standardize the data, to normalize the data. That's all. So we put relative risk on the y-axis and all different studies on the x-axis. Are you getting the point? All different studies we are going to put on the x-axis and all different outcomes we are going to put on the y-axis. This is study number 1 that is conducted by Henrich, where this is the pooled estimate that is in the red color. If you can see this red dot, this is a pooled estimate. A collaborative group has got the pooled estimate of this much. And if you see all these components, I'm just going to depict you, this is the outcome and these are the studies, and 0 is a null value. Okay, now if you look into this particular graph, you may see that there are a lot of studies which are giving the estimate above the null value, means a statistically significant value. Okay, so if you look at these lines, the central red point is going to give you the estimate, the relative risk of this particular study, and the upper and lower dots lines are going to tell you what is the standard 95% confidence interval. Can you see this? This upper and lower point gives a confidence interval, and the center point, central red line, red dot is going to tell you what is the effect size or individual relative risk of that particular study. Now, look at this graph. This graph has got multiple big lines. My question to you is, where is a pooled estimate? Where is a pooled estimate? If you look at the pooled estimate here, it is lost somewhere between these big lines. And here is a pooled estimate, which has got blue dot. And these are the 95% confidence intervals for the pooled estimate. If you see this graph, you get lost with what are the different, estimates, and where is my pooled estimate? And with lot of curiosity and with lot of effort, you will be able to find the pooled estimate. I want you to concentrate on one more thing here. If your pooled estimate or pooled odds ratio is having less range of 95% confidence interval, the variation, if it is less, you consider it to be most accurate. But if you see here, there are 4 big lines which are having very high 95% confidence interval ranges, and you will concentrate on them. They attract your attention. But ones which actually need to attract your attentions, which are the blue lines, which are having very small confidence interval range, which are most accurate findings of your study, you are not finding them anywhere. After, with lot of concentration, you are going to find it. So that is the reason this type of a graph is very difficult to interpret. To get rid of it, we came out with this type of a graph. We call it as a modern forest plot, where I just wanted to bring to your visualization that why it is called as a forest. If you can just imagine, each one of these bars are the individual trees, and you are going to stand in if you just make all these as a trees, you are going to stand somewhere in the center where you are not visible. Okay, so to get rid of it, the same graph has been modified in this present context, where the central line is the null value, where in this particular study it is 1, and all individual studies odds ratios, or the estimates of individual studies, are depicted as squares, and the pooled estimate is, or the effect size is mentioned as a diamond shape, symbol or diamond shape depiction. Okay, this is going to be the pooled effect size. You can read between the lines if you want to know there are different sizes of these dots, right? This one is relatively bigger, this one is relatively smaller, this one is relatively smaller than that. Yesterday I was just seeing the question answer components. Someone was asking the question answer segment, how do you weigh the studies? This is all based on the weighment of the studies. What is the level of contribution this study gives to this pooled estimate? That decides what should be the size of this dot. This study contributes highest to this particular pooled effect size. This will be having a larger size of this will be having the larger surface area or the size. Okay, so based on the weights, based on to what extent the estimate, my present study estimate, is contributing to the overall estimate, is depicted by the size of that particular dot. If the 95% confidence intervals, if you look at this graph, yesterday Krishna was telling, I'm just re-emphasizing it. This 95% confidence interval, this is a lower bound and this is the upper bound, and this lower bound is crossing the null value. This means this study is not yielding statistical significance. If you look into the upper and lower bounds here, you are seeing the null value that comes in between 0.74 and 7.98. The null value, that is 1, that comes in between both of them. And if you look at this particular study where the null value doesn't come, okay, so it is 2.3 to 30.6, the null value is 1, which falls below it. So this study is not, this study is statistically significant. But if you look at the contribution, this study is contributing least compared to rest of the things. The reason is there is a wide range of 95% confidence interval. It is somewhere between 2.3 to 30. On the other hand, if you look at this study, which has got, even though the least odds ratio, the 95% confidence intervals are very, very small. And if the 95% confidence interval is small, it means that your estimate is more realistic. The estimate is more accurate. Okay, so this is what we call as, you can also depict in this entire forest plot individual studies and number of raw data. We call it as a raw data. 12 by 24 received metoclopramide and 7 by 24 received placebo. This is the raw data of this particular study, and this is an estimate of this particular study. This study with this raw data came out with odds ratio of this much. Your entire picture of meta-analysis is very crystal clear here. You are saying what was the raw data, what was the study, when it was conducted by whom or something, what was the raw data and what is the odds ratio. This study is more replicable. And at the end of this entire graph, okay, so you will see there is something called as two heterogeneity tests, which we are going to discuss about it a bit later. So is this graph clear? If there are any questions related to it, please pose it to me. I think Ravindra sir, you can unmute few of them if required, Subuk, so that if there are any questions, I am just going to address. Heterogeneity, I am going to talk Pravalika a bit later. If there are any questions in this forest plot, please let me know, put it in question answer session, question answer segments. Then we will proceed further. I want to just stop here for 2 minutes. Yeah. Krishna, if you want to add anything over here, you can add. I'll proceed further.
Thank you, sir. Thank you very much for explaining the forest plot very well. I think one thing maybe we can add more upon this here is the weightage. I think in this particular forest plot, there is no weightage component. Maybe we can a little bit add on that.
Yeah, and my next slide is on weightage. So
yeah, sure.
I'll just talk about weightage. Okay.
Sure. Yeah.
Thank you, Krishna. Thank you, Sunila ma'am. So we'll proceed further. Yeah. This is what I wanted to depict here. Here you are going to put the study, and here you have odds ratio, and here you have test for heterogeneity. Everything has come together. So this is what yesterday we had a question. The weighted average is going to tell you what is the effect of individual trial on the summary statistic. This is an individual trial which has got the effect of 2.43, which may look very less. But what is its influence on the overall effect size of the study? We need to estimate it. That is called as a weightage. To what extent, what is contributing to the outcome of your study? You call it as a weight. To calculate the weight, we usually divide the variance of the trial estimate. That's the variation in the your estimate by 1 by that trial estimate, or 1 by the square of standard error. Just imagine if a study has got large variance, this study is going to be of less use. That is the reason we take a inverse of it. And if the study has got a very less variance, it is going to contribute more. And this is just a small methodology. I will not directly divide 1 divided by 0.4 is not going to give you the weightage. You need to calculate weightage for individual outcomes, and you need to multiply it with the actual effect, add them and take an average of it. That is what we call as a final estimate of the weightage. It is a statistical procedure. It can be easily done by the statistical softwares that are going to give you the weighted. What is the amount of weightage that is contributed by this particular estimate to the pooled estimate? You can easily calculate it by the software. But please remember, weightage is nothing but what is the level of contribution an individual study gives to the overall estimate. And that is nothing but 1 divided by the variance that is there in that particular study. You call it as a weighted average. And based on this, we decide which study contributes well, which study doesn't contribute much. There may be some studies which do not contribute at all. Those studies can be removed at the end of the day if you are really interested in removing them. And some studies are contributing heavily, you can retain them. And it is all dependent on how you proceed further. I think I made this weightage concept a bit clear, but at least understand you are not manually going to calculate the weightage, because you may be having 100 different studies calculating effect size, all of them is going to be a difficult task. The statistical softwares are going to do it, but to feed to the statistical software, you need to have either a variance or you need to have the standard error of that particular of different studies. If you feed it, the study itself, the software itself is going to give you the weighted average of that particular study to the overall estimate. This is a simple thing. If you just look at this graph, this is a weight that is given by these studies to the overall estimate. For example, this study has got 34% of weightage, this study has got 24% of weightage, this study has got 15.5% of weightage, and this study has got this much. You are just going to get what is the amount of contribution that is given by each of the studies. I am taking one more slide of Krishna, which seemed to be very interesting to me, so that I can explain about it. Krishna also coming in between. So if you look at this particular graph, there are different studies listed here. And this is hazard ratio of these studies, and this is a 95% confidence interval. If you look at the hazard ratios, you can easily make out the average hazard ratio was 0.2. This is a study which is having least hazard ratio, that is 1.22. But look at the weight it is carrying. It is carrying 16.96% of weightage to the outcome is provided by this particular study, though it is having a very low hazard ratio. Okay, so the reason is the confidence interval. Look at the confidence interval difference between the upper and lower bounds of confidence interval. So 1.06 and 1.43. Okay, so because the estimate is more accurate, so means authors have been very accurate in depicting, in collecting the information and calculating the final effect size. That is the reason the variance has come down. The variation in the upper and lower estimates has come down, and that is the reason this study is contributing largest to this particular outcome. You can just look at another study. This study has got, say, 1.06. It is almost similar to 1. Null value. But if you look at the weightage that this study is carrying, is almost 15.48%. Look at another example. This study has got 2.09 as a hazard ratio, which is an estimate of that particular study, which is definitely more than 1.22. But if you look at the weight it gives, the weightage the study provides to the final estimate is just 1.6%. So that this is the beauty of meta-analysis. If you go with only this study, you will say that there is, 2 times hazard. Okay, and if you go with this study, there is almost no hazard. But when you pull all this data, you are going to get something different, more near to the reality. That is the reason if you do the forest plot, if you calculate the weightages, you are going to have better picture on the outcome of your whole study. Krishna, you want to add anything to this slide?
Sure, sir. Yeah, thank you. I think participants know this first part is going to be very important, and maybe you can understand most of the things. And already Praveen sir explained all other aspects. And maybe I can touch upon a few more aspects. Maybe we can look into this forest plot, especially you can see some correlations. So the correlation is going to be very important here. So how we are going to be correlate, for example, sir mentioned Human 2012 is a study which is having the highest weightage, 16.96. At the same time, Song 2012 is a study which is having the lowest weightage. And those two things you can correlate with one other aspect in the forest plot, that is the confidence interval. So you can see here, the confidence interval is very wider for the Song, and that is the one which is having the very lowest weightage. And the Newman 2012 is having the narrow confidence interval, and that is the one which is having the highest weightage. So that's one correlation we are going to make it up. So whenever the confidence interval is less, and that particular study is going to get more weightage out of overall 100% of weightage, and that's going to be influenced more the overall estimate compared to any other study. And maybe statistically speaking, on what maybe which is going to be influenced that particular confidence interval, I think maybe Sir can explain better on that. Usually it's going to be the sample size. So how many people are involved in the particular study is going to be influence the confidence interval. So simple to say, when the number of people are more in one particular study, and obviously the confidence interval is going to be narrow. And whenever the confidence interval is narrow, and that particular study is going to have more weightage, and that study is going to be influenced more on the overall effect estimate. Okay, that's one point maybe we can try to understand here. And another one, maybe you can see some square sized boxes behind the diamond shape for every study. Behind the diamond shape, you can see some square shaped box. And once again, that box also is going to be indicate the confidence interval. So you can see now, whenever the box size is bigger, the confidence interval is narrow. For example, a Newman, the box size, the square box which is set behind the Newman, it is going to be bigger compared to the Song 2012, where we cannot see at all the box, right? So that's once again is going to be indicate the confidence interval of a particular study, and this kind of boxes you may or may not going to be seen in all forest plots. And that's the reason I kept this forest plot from almost from 5 years, where we can explain much better about the forest plot. I think that's what from my side, sir. Thank you.
Yeah, thank you, Krishna. Thank you very much. I was missing this this box which is behind the diamond. Thank you so much for this. And you need to concentrate on this also. You can just see this box. This is almost merging. I don't know whether you are able to see it very clearly or not. We'll be sharing the slides with you. You can just have a look at it. And if you look at this is very almost attached to the diamond. And if you see, this is quite bigger, very evident. Those who are from medical background, you can correlate it with vaccine vial monitor, which is used for polio, where you are going to see the square and round, the variation in the color. It is easy to interpret. Thank you, Krishna, for bringing that. Thank you so much. I'll proceed further. So when you are estimating the outcome, there are two models. One is something called a fixed effect models and something called as random effect models. The fixed method models, as the time is fastly moving, I'm just going to give you the concept of it so that we can proceed further. The fixed method models, you are having fixed ideas. This is going to happen. You are almost like one-sided hypothesis. You know that this is going to happen. Just like magnitude, this treatment has got this effect. This treatment has got positive effect. This treatment has got negative effect. And this treatment is better than this treatment. Or this treatment is less better than this treatment. You are having some kind of an idea already. Your ideas, the model is fixed. And at that point in time, you are going to use a fixed method models. And in fixed method models, there is not going to be much variability between the studies. And within the study, there can be variation. That is common. And if it is a fixed method model, is applicable for the studies which are having low heterogeneity. And most of the studies may not be having, low heterogeneity. Sometimes you may not be knowing what is going to happen at the end of the day. You are very much unsure about the heterogeneity. There may be a lot of heterogeneity in the study. In that context, you may use something called as random effect models. Someone is asking the question in the question and answer session. Answer to your question is, if there is a heterogeneity, you can go for random effect models. And most of the time, if there is more heterogeneity, we do not compare only. We will drop out. We will not compare at all. We will not include that part as that topic as a part of our meta-analysis or not, at all. But on the other hand, if you feel that heterogeneity can be considered as one of the important component of analyzing, at that point in time, you can still consider those studies, and your statistical analysis method is going to be different. You are going to do something called as a random effect models. So to depict it more graphically, in fixed method models, you are sure the distribution is very much clear. It is almost corresponding to each other. Most of the time, the results are going to be consistent with each other. Okay, and you are sure about there is no heterogeneity. But on the other hand, this is a random effect where you are not very sure what kind of effect can occur at what point in time. But the effect, whatever happens, it is going to follow some sort of a distribution. Okay, so when you are planning to do study with the fixed effect model, you are going to use mental Hansen's method, and if you are planning to do the study, if you are having more heterogeneity, and if you are if you want to use the random effect method models, you can use something called as Dressmonian and Laird method. So these are some statistical methods that are usually used when we are calculating, when we are doing the fixed and random effect models. There were a lot of questions on heterogeneity. I am left with another 5-6 slides. I just want to finish them off before that, before 10:15. If there are any questions, we'll address in the next 15 minutes. Heterogeneity, there are, in simple words, heterogeneity is nothing but a variation. There could be two types of heterogeneity. One is a clinical heterogeneity and second is a statistical heterogeneity. Clinical heterogeneity is a rule because every patient is different. And we usually neglect this clinical heterogeneity. And how we measure actual heterogeneity is through the statistical heterogeneity. Why the statistical heterogeneity occurs? Because the studies will be having different sample sizes. Some studies may have lesser sample size. Some studies may have larger sample size. Some studies may use different type of interventions. And some studies may use another different set of interventions. And some studies the criteria for the definition of a particular effect is different, and in some studies the effects are different, and the sample size, sampling technique, inclusion, exclusion criteria. If you download 100 articles, in all 100 articles you do not expect all of them to have a same inclusion, exclusion, definitions. Everything cannot be same. In that context, we will have some kind of a statistical heterogeneity. And the statistical heterogeneity has to be measured, it should be documented, and if it is in the acceptable range, then the studies can be compared. If the studies are not if the studies are not comparable, then just leave those studies off. A simple analogy is, apple can be compared with apple. Apple cannot be compared with orange. If you compare apple and orange, it becomes apple-orange sandwich, which looks very weird. On the other hand, if the apples are there, apples could be of different color. Apple can be of different size, different shape, but still they are apple. They can be compared. So that is a rule of heterogeneity. Okay, if whenever you are doing the systematic review or meta-analysis, you need to compare the studies which are comparable, and at least the outcome variable of these studies should be comparable with each other. And if they are not comparable, we consider there is no heterogeneity and we are going to reject it. How to test the heterogeneity? There are 3 simple ways in testing the heterogeneity. Just look at the graph. Forest plot. Just look at the forest plot or the funnel chart, whatever you want to look at, and look at the contribution provided by each of these studies. If there are few studies which are having very large confidence intervals, and you won't get any kind of a picture in the forest plot, it itself means that the studies are heterogeneous of each other. And one study is having 16 hazards ratio, another study is having 120 hazard ratio, one study is having 2 hazards ratio. It means that the studies are variable. Just look, this is called as eyeball test. Just look at it. On the other hand, there is another way of doing it is through statistical test. There are 2 tests which we usually use. There is something called Cochrane's Q test, which is nothing but a chi-square value. Okay, so you must take care. The studies with small sample size, that's what Krishna was trying to tell. The studies with small sample size, which are not very authentically conducted. I don't say studies with low sample size are all not authentic. Some studies with low sample size can be done in more authentic manner. But in the meta-analysis, when you are considering, there can be some studies with very low sample size, having very low power. The contribution given by them to the heterogeneity sometimes may get neglected. That is the reason when you are taking the heterogeneity p-value, we do not take heterogeneity p-value as less than 0.05, we take it as 0.1. Please remember this particular concept. So when you are doing the test for heterogeneity, the p-value is not less than 0.01. What is a null hypothesis in heterogeneity? There is no heterogeneity between the studies. Okay, so you need to disprove this null hypothesis to say that there is some amount of heterogeneity. Okay, so to say, for example, there are test studies and your hypothesis is that there is no heterogeneity, the null value. If your p-value is more than 0.05, you are rejecting this null hypothesis and you say that there is a heterogeneity. If it is less than 0.05, it means that you are going to say there is a significant heterogeneity. So that is the reason when you are doing the heterogeneity Cochrane test or the chi-square test, please keep this 0.1 as your p-value. If the p-value is less than 0.1, it means that there is a significant heterogeneity. If it is more than 0.1, it means there is no significant heterogeneity. Okay, so please remember, if only p-value is not statistically significant means that there is no heterogeneity, you need to always consider what you call as the clinical parameters which are contributing towards this heterogeneity. Another way of doing it, this looks a bit confusing, this looks a bit difficult to interpret, and this has got a very large influence, largely influenced by the sample size. To get rid of it, we go for something called as I-square statistic. It is going to tell about what is the consistency, what is the level of inconsistency between the effect size values. Okay, it is a percentage of variability in effect estimates that is due to heterogeneity. Is a variability in the effect estimate? What is the percentage of the variability in the effect estimate is contributing to the final outcome? So that is estimated by I-square statistic. If the variability is 0 to 40%, we say it is not very important heterogeneity. Okay, if it is 30 to 60% may represent moderate heterogeneity. If it is 50 to 90% may represent substantial heterogeneity. If it is more than 75%, it means that there is a very large heterogeneity. If the I-square value is 75%, it means that the variability in the effect estimates is almost 75%. Okay, so then that variability, that kind of heterogeneity cannot be accepted. This is what we call as a I-square statistic. This is what is mentioned. I was talking to you in my previous slide. When you are testing the heterogeneity, it means that your chi-square value, this is your Cochrane's chi-square, is 4.91. And if you look at your p-value, this is 0.086. This 0.086 is less than 0.1. So it means that there is a significant heterogeneity. Okay, and the test for overall effect we are going to discuss a bit later. Okay, this is the test for heterogeneity. If the heterogeneity is significant, it may, you need to commit in your study whether there is a significant heterogeneity or not. Coming to the next very important component, that is publication bias. How do you exclude the studies how do you come to know that there was publication bias in your meta-analysis or not? It can be done using a very simple tool is to do what is called as a funnel plot. Okay, this is what we call as a funnel plot. And in funnel plot, we usually depict effect size of any study against the precision or the systematic, standard error. You put the effect size against the standard error, and these are all the contributions of the effect size of individual studies. If you look at the effect size of individual studies against the precision, you see these points are symmetrically distributed across the effect size. I will show you one more graph. This graph and this graph, try to compare both of them. Here, authors have included the studies, though they are not giving you a desirable or the non-significant results. These are all the studies which are giving you a favorable outcome. For example, if you say this is a favorable p-value and this is unfavorable p-value, most of the studies in this are giving both the favorable as well as unfavorable p-value studies, the favorable and unfavorable results, and they're all symmetrically distributed. Look at this graph. This graph, in this particular study, most of the studies which are giving significant findings, they're all depicted, and the studies which are giving less significant values, which may not be, where your p-value is less than more than 0.05, the outcome of the study, those studies are not reported at all in the study. It means that this graph is asymmetric funnel plot. So it means that there is a potential publication bias in this particular graph. If you look at this, though the picture is blurred, but I found it very attractive. If you look at this particular funnel plot, the others, this is what we call as a favorable outcome, and this is an unfavorable effect size, and this is a median effect size. And others have taken all care that all the studies, whether the favorable or unfavorable responses, they're all put together over here. There is no much bias. On the other hand, look at this graph. Unfavorable results are not at all depicted. It means that there is a potential publication bias in this study. To make it more comprehensive, it's a very easier way of assessing whether the publication bias is there or not. On the other hand, there will be some statistical test, something called as Begg's rank correlation test, and there is another statistic called as Egger's regression analysis, linear regression, that we usually do when we are doing the publication bias. I just want to introduce you to these concepts so that you can just remember them and we can discuss about them whenever there is a need. So Beck's rank correlation test is, all of you know about the correlation, right? Sometimes when there is a publication bias, the effect size of a particular study correlates with, correlation is nothing but as effect size increases, the variance increases. As the effect size decreases, variance decreases. There is a positive or negative correlation. If there is a strong positive or negative correlation between the effect size and the variance, it means that there is a publication bias. I will show you this example. This is a simple funnel plot. Are you all getting? This is the funnel plot. If you look at this, few studies seem to be missing. This is not very symmetrical. Here, if you take few studies seem to be missing. But by looking at it, this I come to know that there is some amount of publication bias. So what I'm going to do now is, I'm just going to turn this entire funnel plot. This is exactly how your correlation plots look like. The scatter plots look like, right? So if you see here, most of the results are having in line with the correlation, no correlation line. This line says that there is no correlation, zero correlation. And most of your findings are in parallel to this line. It means that there is no correlation. On the other hand, I will just show you one more graph. Yeah, sorry. This graph, this is no correlation line, and most of your observations are around this. And if you look at these lines, these dots, which show some level of negative correlation. And the point you need to keep in your mind that whatever observation dots you see, they should not follow either a positive correlation kind of a picture or negative correlation kind of a picture. They need to be in parallel with the correlation line, no correlation line. Then it means that there is no statistically significant correlation. It means that there is no publication bias. On the other hand, a very simple and more exhaustively used method of publication bias is Egger's linear regression test. I think all of you know about the regression. We've all attended statistical analysis software workshops. So it is a level of prediction. To what extent the information that is coming is predicting the publication bias. So in case of regression, we always go with this intercept. So intercept is nothing but wherever the slope touches the y-axis, this is called as the intercept. And if the study is not having publication bias, the intercept is going to be 0. If the study is having publication bias, the intercept is going to be more than 0 or less than 0. 0 is nothing but a null value. If you look at this particular study, if you see beautifully the correlation, positive correlation is depicted here. And if I draw a line to the y-axis, it is going to meet it just above 0. It means that there is some amount of publication bias associated with this. If you look at this graph, the intercept is going to meet the y-axis exactly at 0. It means that there is no very strong kind of a publication bias. This is what we call as a Eggers publication bias test. Now I just leave it to Krishna. Krishna, please explain about this slide about interaction as it is from your own study. I just want you to give the first.
Yes, thank you. This is one more statistical analysis we are going to perform, especially when we go for the subgroup analysis. Here you can see one of the meta-analysis we have conducted on statin use and risk of breast cancer, where we have taken the observational studies to see the relationship between the statin use and risk of breast cancer. And the first meta-analysis we have done, the main analysis we have done by using 24 studies, and you can see the pooled estimate is 0.99 and the confidence interval is 0.94 and 1.04. So by seeing that, we can understand that the overall understanding, the overall conclusion of the study is there is no relationship identified between the statin use and the risk of breast cancer, right? So what we have done further is we have divided all the 24 studies into different groups based on a particular characteristic. For example, based on the study design, we have divided the studies into cohort and the case control, right? Because we have included 13 cohort studies and 11 case control studies. So what we want to see is if you do the meta-analysis just by using cohort studies, what's the outcome we are going to get? And if you use a meta-analysis just by taking the case control studies, what is the outcome you are going to get? And finally, we need to understand, is there any difference between a cohort study outcome with the case control studies outcome? So that's what we have done. You can see here, the cohort study, we got the relative risk of 1.01. And the case control studies, we got the relative risk of 0.95. Of course, both are found to be not significant based on the confidence interval. And for that, what I want to explain in this is 0.35. So there's something called P interaction, that is 0.35 for this study design. So the meaning of this 0.35 is here the P value is like a standard P value, what we are using in the basic statistics. 0.05 is the cutoff value. Whenever you see the P interaction value less than 0.05, if it is less than 0.05 P interaction value, then we can say that the outcome from cohort studies and the outcome to the case control studies is significantly different. So what are the outcome we are getting for the cohort studies and what are the outcome we are getting for the case control studies? Both the outcomes are significantly different whenever the P value is less than 0.05. So in this case, we got 0.35, that is of course more than 0.05. So we can say that whatever outcome we got from the cohort studies and case control studies are found to be not statistically significant. That means almost both are going to be same, whatever we are getting the outcome. So like that, whenever we go for the subgroup analysis and come out with the 2 different pooled estimates or 3 different pooled estimates. So just to understand that, is there any significant difference between these pooled estimates? We are going to do the P interaction test. And if the P value is less than 0.05, we can say there's a significant difference. Otherwise, we are going to be say there is no significant difference. I think that's what we can understand maybe from this.
Yeah. Thank you, Krishna. And Krishna has also applied something called test for publication bias, is something called Beggs and Eggers. Usually both tests are applied, Beggs and Eggers are applied. We usually, after we apply Beggs and Eggers test, we do not give the correlation coefficient, or we are not going to give the adjusted odds ratio. Here we give only the P value. If you look at it, it is only the P value. Its P value is more than 0.05. It means that there is no correlation. Okay, so as per the Beggs test, and if you look at the Eggers test, again the P value is more than 0.05. It means that there is no statistically significant difference. So it means that there is no publication bias associated with all different studies. The P value is more than 0.05. It means that the publication bias has been very well taken care of by the authors when they are doing the when they are doing the meta-analysis or when they are doing the study in that particular setting. So please, final point that we need to remember about the publication bias is the final p-value. It is the p-value for Beggs or Eggers, if it is whether it is less than 0.05 or more than 0.05. If it is less than 0.05, it means that there is some amount of publication bias. If it is more than 0.05, it means that there is no publication bias. It is as simple as that for the interpretation. Coming to the meta-analysis softwares, again I've taken it from Dr. Krishna's slides. There are many. Review Manager is a very commonly used software, and meta-analysis is another software. Epimeta, Easy Meta-Analysis, MetaTest, and Metastat. These are the freely available statistical softwares, and there are few commercial softwares, commercial meta-analysis softwares like Comprehensive Meta-Analysis, MetaWin, and WEasy Meta-Analysis, and general statistical packages like Stata, SAS, and DES+. Even they give the softwares related to analysis of, analyzing the data related to meta-analysis. These are few checklists that are applicable for writing or reporting the meta-analysis. One something called PRISMA, which Dr. Krishna has already talked about it yesterday more clearly, and there's something called MOOS. Okay, MOOS is meta-analysis of observational studies in epidemiology. Sometime if we just put the PRISMA, there are many PRISMAs. Okay, so you need to Google or you need to search as PRISMA checklist for systematic reviews and meta-analysis. Then you will get a PDF of checklist that you can easily use. Okay. Coming to the last slide on the challenges related to meta-analysis, one most important challenge most of us face is the lack of expertise associated with this particular area. And sometimes there can be poor reporting practices. In our studies only, when we are reporting, when we'll be analyzing, when we'll be reviewing the papers, we just get to know that people mention mean values and they don't mention the standard deviations, which is most important. People don't mention standard error. People mention odds ratio, they do not mention 95% confidence interval in their final papers. Such improper, though the study is very well conducted, if the outcomes are not very well defined, not very well described in the paper, that paper will be not of great use, that we cannot use in our final analysis. Okay. Next is varying level of instruments used in the reliability, especially when we are doing systematic reviews related to the depression, suicidal tendencies and all. There you'll be having different type of tools will be used for data analysis. So the instruments will be of different reliability. So it will be difficult to compare the instruments having different level of reliability. Sometimes inconsistent research activity or idiosyncratic research activity where everyone wants to do the study with their own intuition, that becomes a very, when we are collecting this information, this will be very difficult to collate. Next is, few studies are replicable deficient. Few studies cannot be replicated. They are not replicated at all. Similar studies are not conducted elsewhere. You'll be getting only one or two different studies and it will be very difficult to interpret out of it. Okay, and disagreement over definitions and operationalizations. Especially it comes with the definitions related to before this WHO came out with Asian Pacific guidelines for obesity. At that point in time, we used to go for WHO obesity guidelines, BMI classification. And if I want to do any type of a study now, there will be few studies which will be reporting WHO classification, few will be receiving Asian Pacific classification, then cutoffs are going to be different. So at that point in time, the comparison becomes very difficult. We will be over-relying on few studies which we feel are very important. And we tend to forget the studies which report the study, the findings in contrary to what we think that is more important. Okay, so we rely on few studies. Over-reliance on few studies is another component that is responsible for publication bias. Okay, sometimes the bias of primary or secondary researchers towards particular type of studies or findings, results, even that is going to have a very major impact on the overall outcome of the entire. To summarize what all things we discussed today, we discussed the essence of meta-analysis. We just took forward from what Dr. Krishna has told yesterday. We discussed basically on the interpretation of forest plot. We discussed heterogeneity, and we discussed about and what are different softwares available for meta-analysis, and also we saw what are the challenges associated with meta-analysis. So altogether, meta-analysis is collecting the studies, more number of studies, okay? And if you take more studies in, the information that comes out of it is going to be more. But you need to keep in mind that these studies which you select should be scientific, they should be of good quality, and they should be contributing to the final outcome of the study. Okay, so with this, I thank all of you for listening, and if there are any questions, you can ask the questions, and Dr. Sunila is going to moderate it. Thank you so much.
Thank you, Dr. Praveen. I suppose, Dr. Krishna, can you go ahead with the questions of yesterday? There were a few questions already answered by now, but there are a few more questions, and I want Dr. Krishna to proceed with that. Do you want me to read the questions for you?
No, ma'am. I have the Excel sheet what you shared with me, so I can take it up. I'm glad, and I thank to Praveen sir for answering almost all the questions. Maybe there are a few more. Maybe I can just answer quickly.
Yeah, we have another 10 minutes only. Okay.
Sure.
Yeah.
So about the weightage, we have already covered extensively, and the Cochrane library includes articles on RCTs and cohort studies. So just to mention, the Cochrane library, under the Cochrane library, there are various domains. One particular domain is for the Cochrane Central, and that is mainly meant for RCTs. So in the Cochrane, we are not going to get any observation studies like cohort, case control, or any other types of studies. It is only for looking for RCTs, randomized control trials. And can keywords be more than one word? Yes, of course. So we can have more number of keywords. So when you have a more number of keywords, your search is going to be very standard, and you're going to get a very good amount of literature, and very accurate literature you're going to get when you have more than one keyword. And as I mentioned yesterday, keyword alone may not be sufficient. In PubMed, it is okay, because once you type the keyword, especially in the new interface of the PubMed, once you type the keyword, it is automatically going to take up all the synonyms of that particular keyword in the new interface of PubMed. But when you're searching in other database, along with the keyword, you need to search even the synonyms as number of articles in other databases. And the other question is, since there is no free access to Embase, will there be a significant loss in literature that we gather for our systematic review and meta-analysis? That is going to be, may not be a limitation for meta-analysis. As per my understanding, whatever we are going to be looking to the Embase, almost everything will be available even in the PubMed, except some conference abstracts and some other journals which are not there in the PubMed, the European region. Apart from that, we are going to get each and everything from the PubMed. So if you don't have the access, I think you don't need to bother, but still you can conduct the search in PubMed and you can go ahead with that. And while performing the meta-analysis, how important it is to include unpublished studies. I think it depends upon our hypothesis, especially if your hypothesis is something very new. Maybe let's say that your hypothesis is on COVID-19, hydroxychloroquine, or any other management issues. You know that currently there are many trials which are going on. So in this case, certainly it is important to check for unpublished information as well from the sites what I mentioned yesterday. And then you can get some information which is available from those sites. Let us say that maybe if you're doing something on aspirin, okay, aspirin and any other outcome, gastrointestinal outcome, something like that. If you're doing any meta-analysis on that aspect, so people don't expect that you are going to be search for unpublished information, because currently hardly there will be any other studies going on that particular aspect, because it is very well established already, right? So it is going to be depends upon our hypothesis. If your hypothesis is very new, and if you feel that there may be some studies that are going on, then you can go and search for the unpublished information. And can in vitro studies be included for a systematic review? Certainly we can include in vitro studies in a systematic review, but we cannot combine that with the in vivo studies. So you have to make sure that either you are doing any in vivo or only in vitro. we cannot combine in vitro with the in vivo studies because those are going to be completely two different things. So if you want to do a systematic review only by using in vitro, certainly maybe you can take all the studies in vitro and then you can go for the systematic review. That can be possible. And the registration for systematic review is mandatory for registering. It is up to you, especially in the Prospero. There is one website called Prospero from LA University, PROSPERO, Prospero, where you can go and register your protocol. As I mentioned, each and every systematic review, we need to have a protocol. Once you come out with a protocol, if you go, you can go and register there. And as mentioned by Praveen sir, the advantage there also is, if you go and register the protocol there, you need to send it to them, and they can suggest if any modifications are required in the protocol. So you are going to get some inputs from them. Based on that, you can modify the protocol and you can do a very good meta-analysis. But of course, it is not mandatory for registering the protocol. And whether we have to register before conducting a systematic review and meta-analysis, it is not mandatory. But for Cochrane, if you want to write any Cochrane systematic review, certainly we need to write the protocol first, and that should be registered with the Cochrane, and the Cochrane will even publish that protocol, and later maybe you can work with a full text article. For Cochrane, it is mandatory. If you're doing a meta-analysis for your purpose, or if you want to publish maybe general meta-analysis, in that case, it will not be mandatory. And how do you set the outcome? The outcome is entirely based upon the hypothesis once again. And once again, the outcome may be based on what kind of studies you are going to be getting. When you search for the studies, if you're getting the outcome only the mortality, certainly you can include only the outcome as a mortality. And along with the mortality, maybe in some studies, if you're getting the outcome as a stroke, myocardial infarction, in that case, you can include those also as an outcome. So outcome set is going to be depends upon what kind of studies you are going to be get and what's the information you are getting from the studies. And systematic review is used in industry. Certainly, in industry, there will be a separate wing, especially for multinational companies. I know personally the Novartis, where they have separate people who are working for systematic reviews and meta-analysis. They paid very well. So certainly they need to get some information for their products, and they will have a team of people who are working for the systematic review and meta, and certainly they're doing that work as well. So if you have the concepts, I think it's going to be useful to join in industry also in that particular area. That's what the questions, ma'am, I have. Thank you so much.
Yeah. There's one last question addressed to Dr. Praveen for today. Does SD include odds ratio? I think that was not answered.
No, actually, I think Krishna has already answered this question.
Actually, SD is mainly meant for the mean standard deviation. Odds ratio, for that we are going to have the confidence interval. So both are two different things.
Ma'am, I'm seeing one question popped up by Nandalal sir. Sir, very good morning, sir. Thank you very much for joining the webinar. It really, you have brought the webinar to a very different level after joining. Thank you very much, sir, for being with us. Sir, actually, some studies are reporting mean and some reporting percentage. So what we would be doing, whether we are going to merge or do you recommend to recalculate? Sir, actually we cannot merge both of them. They are different entities. If some studies are reporting mean, and we need to take the mean separately, and if studies are reporting percentage, we need to report them differently. So when we are doing meta-analysis, we don't calculate anything for the authors. Whatever authors have done, we are going to take the data from those papers and we are going to collate the information. We cannot recalculate. And if there is a mean, we take only the mean component of the study, and if percentage are there, we are not going to take when our outcome that we are going to assess is a mean. So at that point in time, we cannot recalculate, and it is better to exclude the studies where different outcomes are put in a different way.
All right. So we come to the end of the question session. I thank all the participants and the viewers, including sir, for their highly enthusiastic interaction across the sessions from yesterday and today. And profoundly thank both the speakers from Dental Education Unit, institution, and myself. I have joined with me is Dr. Ravindra sir. I request sir to give his closing remarks for the highly interactive and made easy, simplified systematic review meta-analysis sessions. Sir, over to you, sir.
Good morning. I first of all like to extend my heartfelt thanks to Dr. Krishna Undela and Dr. Praveen Kulkarni for accepting our invitation. And I am sure this webinar was very informative and need of the hour. I once again thank both of them for accepting and presenting excellent informative lecture. I also thank Dr. Sunila and DU member for organizing this webinar. I thank all the participants for participating. Thank you one and all.
Thank you, sir.
Thank you. Have a good day.
Thank you, sir. Thank you so much. And so we come to this end of the sessions, but there's a long way to go ahead. And I think you have helped us to at least, now, I personally feel I am now at least equipped to read a systematic review published article. And as rightly said by you, a methodologist is required to conduct a systematic review. That is very rightly said. Thank you both for this extremely well done, well informative, enthusiastic participation, and we request more from both of you henceforth. Thank you so much. Thank you so much. Thank you all the participants and viewers. Thank you. We come to the end of the session.
Thank you, Praveen sir, for joining with me.
Yeah, ma'am. Thank you, Krishna. Thank you very much. Thanks. It was a learning experience. Thanks a lot.
Thank you, ma'am.
Sir, and we need to thank Sumukh. Sumukh, thank you very much. Sumukh was the one who was coordinating everything.
Thank you so much.
Thank you, Sumukh. Yeah.
It was a very good presentation.
Thank you so much, Sumukh. Thank you.
Thank you, sir.
Go ahead, and thanks a lot for your support.
Yeah. It was clean today night.
Thank you.
Thank you, ma'am. Thank you so much.
Yes.